Hello everyone, welcome to the third video of IAL Edexcel Physics Unit 2 model answer. Uh, in this video we will give you the model answer from question number 14. So let's start. A student investigate the power uh, that a battery can supply to a circuit. A student connected a circuit to determine the electromotive force, okay, and the internal resistance R of the battery. The load resistance R was varied. The corresponding reading of current I and terminal potential difference V were recorded from an ammeter and a voltmeter. This is the circuit diagram. State what is meant by EMF. So EMF is the work done per unit charge. So EMF is basically work done per unit charge inside the battery in order to move charge from the battery into the circuit. So this is basically the formula, or you can say this is the definition of the EMF. But if you wish to write, you can write EMF is the energy per unit charge converted from chemical or whatever the source is to the electrical energy. This is the definition. Okay, part B. Add to a circuit diagram to show the position of ammeter and the voltmeter. A typical question that generally comes in electricity question. We need to mark the position or draw the position of the voltmeter. So ammeter is always connected in series, and this is the battery, this is the resistor. I can put ammeter in outer loop in anywhere in series, so I can put ammeter here. This is my ammeter, and my purpose is to find the internal resistance or study the cell. So I need to put voltmeter around the battery. Sorry for that. It must be, yeah, okay, voltmeter parallel to the cell. Okay, so whilst taking the measurement, the student reduced the resistance of the variable resistor to 0 and suggests why this could be problem if battery has a low internal resistance. Okay, so if we reduce the external load to 0, if it become R equal to 0, then large amount of charge will pass through the battery. It will produce a heating effect, and the battery will discharge quickly, or you can say the heating effect. So we can write like it will cause heating effect. A battery terminal would be short circuited. If you wish, you can add it will be burned or maybe discharged quickly. Okay, so let's see the next question. The student plotted the result on the graph. VI graph, determine the value of for epsilon and R, internal resistance. So first we need to draw a best fit line. This is the line, and using a ruler you can draw the line. Let's see if it will be something like that. Okay, so this is my first line, best fit, and determine the value of the resistor. Everything is fine, I guess. So from this graph you can see this y-intercept is called your EMF epsilon, and which is epsilon is your 6 volt, and for internal resistance R you need to find the gradient of the line. For gradient of the line you need to choose any two points on the graph. So it depends on your actual graph. So I am taking 2 points, like you can say it's so So I will choose, I guess, this point, and you can take any other, but the triangle should be large in order to get the better answer. So for, I'm just taking this point. If you find the gradient, this is your rise and that will be your run. So rise over run is your gradient. So your resistance R would be equal to y2 minus y1, which is 5.1 minus 1 from my chosen point, I guess. And x2 minus x1 is, I can say, is, what if I, instead of this, if I take, let's see, this one. Okay. So it will be give me, yes, okay, fine. 1.2 minus, let's say, 0.2. Okay. So from this calculation, I can have R is 4.1. This is my internal resistance. Okay. For part 2, the power transferred from the battery to the load resistance is maximum when R is equal to R. Calculate the maximum power dissipated in R. Okay, for maximum power dissipation, remember we are given resistors, so power dissipation we can find easily. P is equal to I square R. So we need I means current. So in order to find the current, we use equation E is equal to IR plus IR. And of course, since they have given the maximum power for both resistance R and small r are equal, so if I can plug in these values in the above equation, so I will have E is equal to twice of IR or small r, whatever you wish to. You can even write 2IR, and from here we can easily find I, and I would be equal to E, which is the EMF, divided by twice of the resistance, internal resistance. And current I can have from this equation, if you put the number, E is 6 volt and R is 4.1. If you put these numbers, I will give you 0.73, 0.73 ampere, and use this current from this equation. So P is equal to 0.73 square into 4.1, which is the internal resistance that we found in the previous part. So the power dissipation maximum power is 2.2 watt. This is my final answer. Question number 16. Tungsten is a metal commonly used for the filament in the light bulb. Due to its high melting point, the current in the filament is given by the equation I is equal to NQVA, where V is the drift velocity. The mean velocity of free electron in a current carrying conductor. Explain why drift velocity is defined as the mean velocity. There are reasons, because in a conductor, electron moves with the in random direction with a varying velocity. So if we talk about the velocity of the electron, we need to take the average, or we need to take the mean of all the velocities. So moment of conduction electron is random due to collision, and the electron don't move along the straight path, and electron have a different velocities. That's why we say it's a mean velocity. The diagram shows a free electron in a tungsten filament. A potential difference is applied across the end of the filament. This is free electron. Draw the diagram to show a possible path of the electron as it moves through the tungsten filament. Because this electron is moving due to collision in a random direction, so you can just say something maybe like that. it's random, and it's this zigzag path is due to the collision. You can draw some other path, that's fine. Okay, so in a 12-volt light bulb, the tungsten filament has a length of 1.3 centimeter and cross-sectional area of 7.9 10 to the power minus 11. When the light bulb is first switched on at room temperature, the current is 1.2 ampere. Calculate the resistivity. So for resistivity, we have guess current is giving, length, and of course area. So we have a straightforward formula. Resistivity rho is equal to RA by L. And resistance, so for resistance we can use R is equal to V by I, voltage is 12 and current is 1.2, so 12 divided by 1.2, so resistance will be 10 ohm. I can use this resistance R here, and cross-sectional area and the length, so 10 times 7.9 into 10 to the power minus 11 divided by length. Length is 1.3 into 10 to the power minus 2. Why minus 2? Because of the centimeter. And the resistivity will give the answer after finding the simplification of this fraction. 6.1 into 10 raised to the power minus 8 ohm meter. Okay. Next part, a short time after being switched on, the temperature of the filament has increased. At this temperature, the resistivity of tungsten has also increased. The reference to the lattice of the metal explained why the resistivity has increased. So it's again a typical question, generally discussing about the relation between resistivity, or you can say the resistance and the temperature. Okay, and it's all about the collision of moving electron with the lattice ion. So as electron moves through the conductor, the electron collide with the ions, and due to this collision, temperature increases. Temperature increases, causing increase in the resistance. That's how we explain. So since resistivity is proportional to the resistance, so as the temperature increases, the lattice ion oscillates with larger amplitude, causing more collision between ion and conduction electron, due to which resistance increase. So the resistivity. Suggest why tungsten filament is more likely to break when first switched on, and not after it has been switched on for some time. So at first, when you turn on the switch, a large amount of current that causes a large amount of production of heat that can melt the filament due to high resistivity. A large number of electrons start to move and collide with the filament atom, due to which a high amount of heat produced and can break or melt the filament. Question number 17. It is sometimes difficult for fishermen to see the fish due to glare, which is caused by the reflection of sunlight from the surface of the water. The use of polarizing sunglasses can help to reduce the effect of the glare as shown in the photographs. So without polarizing and with polarizing, we can easily see the fish. Describe what is meant by polarized wave. It's a typical definition of polarization, that the wave oscillates in many planes, is unpolarized, and oscillating in one plane is the polarized wave. So that's how we can explain. Polarized waves oscillate in one plane, which contains the direction of the propagation of the wave. Explain why the fish look darker when viewed through the polarizing filter. So again, The waves that are not parallel to the polarizing plane are stopped and then can help to reduce the glare of the reflected waves. Then we can easily see. So polarized filter only allow oscillation in one plane to pass through. When plane are perpendicular, it causes to reduce the glare. So fish appears dark. Diagram shows two polarizing filters A and B, which could be used in sunglasses. The arrow represents the plane of polarization of light transmitted by the filter. This filter A and this filter B. Um, Vertical and horizontal. Fisherman is being fish that are under the water through polarizing sunglasses. Light reflected from the surface of the water is partially polarized in a plane parallel to the surface of the water. Explain which filter A and B the fisherman should have in the sunglass in order to see the fish clearly. So the light reflected from the surface is horizontally polarized. Horizontally polarized. Remember, from the surface, horizontally polarized from the surface. So in order to stop this surface reflected light, the fisherman should use the filter A. So the horizontally polarized light would be stopped by this filter, and the light coming under the water from under the water can pass through this filter A. So the fisherman should use filter A. As the light coming from the surface of the water is horizontally polarized, the fisherman should use filter A in order to stop the light coming from the surface. The last question. Uh, Diamonds are widely used in jewelry due to their ability to sparkle. Sparkling is caused by reflection of the light inside the diamond. When used in jewelry, diamonds are cut to an optimum shape. The diagram shows the path of one ray of the light as it passes through a cut diamond. Explain the path taken by the ray of the light when it is incident at the diamond air interface at X. So this is X. This is the diamond air interface. Diamond air interface. Your answer should include the calculation. The refractive index is given. So we use the formula refractive index n is equal to 1 upon sine c. We try to find the critical angle. Okay, from this equation we can find the critical angle. So if you use, this is your n, and if you use this n 2.4 here, and if you find n, and so the critical angle will give you 24.6. So critical angle, oh, sorry for that, it's not a, I just check, it's 24.6. Sorry, I just clean it and then I write it again. So 24.6 degree. So you can say the incident angle, angle I, is greater than the critical angle, which is 57 incident angle. So it will, so light would be totally internally reflected at X. Okay, so zircon is a popular, cheaper alternative to diamond. Refractive index of diamond is 2.4. Refractive index of zircon is 2. Explain how higher refractive index causes diamond to sparkle more than a zircon. So higher refractive index cause more light to trap inside, and of course more sparkling due to the high refractive index. But if we can write like, due to high refractive index of diamond, much light entering in the crystal is totally internally reflected and more light trapped inside. And you can add one more thing if you wish. You can calculate the critical angle of zircon. If you do for zircon, CZ would be 1 upon n sine CZ 1 upon NZ. If you do this, so CZ would be equal to uh, 30 degree. So you can say in the previous part, the zircon critical angle is greater than the diamond critical angle. That gives you a range of angle of diamond falls to uh, totally internally reflected light. The refractive index of transparent material can be measured using a 20-degree prism of the material. A ray of light is incident perpendicular to one face and passes straight into the prism. The angle of the refraction R as it leaves the prism can be measured and refractive index of the material calculated. By making suitable calculations, suggest whether it is possible to distinguish between diamond and zircon using a protractor to measure the angles. Okay, so let's see if this triangle is made of a diamond, then we can find the refractive angle using formula sine R is equal to 2.4 sine 20. And if you rearrange for R, then R for diamond, this is for diamond, okay, for diamond. So R would be 55.2 degree, and similarly you can do the same calculation for zircon. For zircon, you can have sine R equal 2 times of sine 20. It will give you R 43.2 degree. So I just do RP, refractive index for diamond made triangle, and this is RZ. And if you find the differences, so delta R is, if you subtract 55.2 minus 43.2, so difference between their refracted angles is 12 degree. And of course the precision of protractor is 1 degree, and we have a difference of 12 degree. So yes, we can use protractor. Okay.